we want to use a vector method to find the position vector of the point of intersection between these lines. So r is -1, I'm going to call this one r1, -1 to -3 plus lambda for -2, 5, and r2 is going to be 1, -2, 2 plus mu -3, 3, -5. Now, if these points intersect, then at some stage the I components must be equal, the j components must be equal, and the k components must be equal. So in other words, -1 plus 4 lambda must be equal to 1 minus 3 mu. Let's call that equation 1. And then we must have 2 minus 2 lambda is -2 plus 3 mu. Call that equation 2. And finally, -3 add 5 lambda is equal to 2 take away 5 mu. Now, choose the first pair of equations because it's easy to get rid of mu. So if I do equation 1 add equation 2, that gives me 1 plus 2 lambda equals -1, and the mu's disappear. So 2 lambda equals -2, lambda must be equal to -1. Substitute in 1, and then we get -1 take away 4 is 1 take 3 mu. So -5 is 1 take 3 mu. So rearranging, that gives me 3 mu equals 6, so mu equals 2. Let's just check that that works in 3. So that would be -3 take away 5 on the left hand side, which is -8, and on the right hand side we would get 2 take away 10, which is also -8. Now we were told they intersected, but you should always do this just to check, because in 3D there's no guarantee that lines intersect. Now to find the position vector, we can either take our value of lambda back to here, or our value of mu back to here. I'm going to take mu to here. So we're going to have 1, -2, 2, plus twice -3, 3, -5. So that's going to give us 1 take away 6 is -5. -2 add 6 is 4, and 2 take away 10 is -8. We did that over here anyway. And so there's our position vector.